Hello and welcome to Powerbench. Today I'm going to be testing this Xiaomi 2i 10,000 mAh power bank. I ordered this one from Banggood. You can get similar ones from Amazon and other UK retailers. This one has Chinese packaging, but it was only £17.80 I think, including shipping, which is a pretty good price. I have reasonably high hopes for this one. It's advertised as 90% efficient. It has two output ports, and most interestingly this one supports QuickCharge 3, which means that it can adjust the voltage based on what the client asks for. So you can increase the voltage to improve the charge rate and reduce loss due to current in the cable. So looking at the specs, I haven't opened this yet. It's been on my shelf for a bit over a month probably now. So 10,000 mAh. It'll charge an iPhone 7 3.5 times, 37 watt hours, which makes sense. 10,000 mAh times 3.7 volts. And it specifically claims it's expecting to do 6,500 mAh at 5.1 volts output, which is interesting because quite often they don't specify that on a power bank. So it's nice to see them actually acknowledging that the capacity is in relation to the voltage. Micro USB for charging as normal, so that's input. It'll do quick charge on the input as well, which is nice, helps it charge up quickly. 2 times 5.1 volts at 2.4 amps. I'm not clear whether that's in total or for both each port individually, but we can find out. It'll do 9 volts at 1.6 amps or 12 volts at 1.2 amps. So the big win of increasing the voltage for a device that supports it is that the higher the current, the more voltage loss you suffer in the cable. So it's much better to use higher voltage and lower current to get the same amount of power, which is the same reason that cross-country power lines and things are very high voltage. The higher the voltage, the less loss you suffer in the cable for the same amount of power. A lot of chargers. I've got a desktop charger here that does quick charge for testing devices as well, and the way I'm going to test that is to use this. Now what it is an Arduino microcontroller with some resistors set up and a pair of buttons which put nice button caps on them to make them obvious, and what this allows you to do is plug it into a USB port, and the Arduino will negotiate the varying quick charge voltages. Now, QuickCharge 2 allowed the selection of 5 volts, 9 volts and 12 volts. QuickCharge 3 allows the selection of any voltage between 3.6 and, depends on the charger, normally 12 volts for smaller devices. Some will go up as high as 20 volts. So the thing that's nice about that is that it means that a device can negotiate what voltage it wants. But trying to test a device meaningfully is difficult. So with this I can actually request a specific voltage, measure it, pull the current that we want, and that's actually a meaningful test. So it looks a bit shoddy, but it does seem to work. So I've tested it with my Anchor USB power supply. Hopefully it will work with this. If not, I'll have to spend a bit of time working out whether it's this or whether it's the power bank, but we'll find out. So opening this up, it actually has a hologram, which is nice. It does seem to be legitimate. Banggood are normally quite good about not sending fakes and things. The box feels nice. It's got a good weight to it. One of the things that's nice about this power bank as well, is that it's got a low power mode. So if you've got something that doesn't draw much current, a lot of power banks will turn themselves off because they don't draw enough current to keep the power turned on. With this, you double press the power button, and then it turns the power at the output on for 2 hours, regardless of how low the current draw is. So if you've got something that doesn't take much current, like a smartwatch or a fitness band or a small lamp, night light or something, this will power it for 2 hours regardless. So that's pretty good. I think that's a good feature. I wish more power banks did that. Somebody has asked me whether I'll be able to test the keep the hold-on current of power banks. It's a bit of a faff, but it's something I'm going to start adding to reviews where possible, I think. So, this is nice. Lovely finish, sort of anodised aluminium. The Mi brand on it. 1 second. Right, sorry about that. So the Mi brand, anodised aluminium, mi.com. There's a bit of information on the bottom. Angle that so you can see. Let's try and adjust the focus. So what do we got here? Can you see that? Yeah. It's the same information as on the box, which is reassuring. So far so good. We'll peel this sticker off. And we've got, I think that's a power button, charge indicators, micro USB port. Let me just adjust the, there we go, brightness a little bit. And 2 USB Type A ports, so if I press the power button, so they light up. So I'm not quite clear what that means, but I think that might mean that it's more or less empty. If it's one blob of charge, which is a shame. We'll find out in a second. What else is in the box? Another box. With a little instruction manual, which is entirely in Chinese, which is not a huge surprise, given this came from China. Oh, so we can open this box. Got nice packaging, it's all recyclable, there's no annoying plastic to deal with, that's nice. And a suspiciously thin charging cable. It's what, 30 centimeters long? Yeah, a little bit more than, I don't know, maybe 35 at a stretch. So I'll test that shortly. So, now the bad news is my normal meter got dropped off a shelf, and when you power it on, the display is now broken. So it does still work, but every other line is now grey, which makes for reading the numbers a bit of a challenge. So I've got a new one on order, but unfortunately can't use that one for now. I do have one by the same company. It's slightly smaller, it doesn't have as many buttons or features, but it is also accurate. The nice thing about this, it does have an OLED display, which is nice, but it's a bit smaller, so it's not quite so good for the videos. And that's fine. Hopefully you can see that. Oh yeah, it's nice and bright. So 4.9 volts, which is what you'd expect as standard for a USB port with nothing clever going on. So let us try with, excuse the cable mess, to try and keep this so that there's a bit of a try and set this up so it can be seen on camera. So it does require power for the Arduino, which is separately supplied. So that power's on. Let me power on this power bank. And if we reset this, hopefully I can turn it on before the power bank turns off. Okay, it's not. Okay. Well, for whatever reason that is not behaving, whether it's because we're not drawing any current, I don't know. So this does seem to think that we're in QuickCharge 3 mode. Oh, there we go, reset. That did just jump up to 12 volts, which is interesting. So, I'm not quite sure what is not happy about here. It could be that when it says QuickCharge 3, actually it doesn't do the voltage selection, because it doesn't specifically mention that. If it doesn't support continuous mode, then these button presses won't work. So I'll come back to that and I'll investigate and have a look. So far, so good. How big is it? The actual device is 146 millimeters long, something like that. It's about 70 millimeters wide and about what's that, 14 deep. It's quite a good size, quite a good weight. It feels solid in the hand. Let's get this out of the way and put it on the scales. So you can see 245.4 grams. What did the box say? It didn't say weight, but the size is as expected. So what we'll do quickly is test the cable it came with, because that's what we do. So I'll turn on the power supply. We'll test this the same way as usual. Plugging in the USB load, and then at 2.1 amps. Just give it a second to settle. Alright. There we go. 5 volts, 2.1 amps. So we know that we've got 5 volts this side of the socket. So we're accounting for any cable loss up to this point, which makes the maths a bit easier. So we'll plug this guy out, have a look at this cable first. So it's kind of rubbery actually, the things, so that there is a bit of strain relief, which is nice. The cable itself feels okay. It's nice and flexible, almost silicone-y. I don't know that it is. I don't think it is actually, but it feels nice. The same on both ends, so decent strain relief. No USB logo on the A side, so you don't get the, which way do I plug it in thing, but there is a little lightning bolt on the micro USB end. That's fine. So we plug that in. Try not to knock this, and we plug it into the right socket. So 2.1 amps. Give it a second to stabilise. I'm quite sure why it's quite so all over the place. jumping around a little bit. Which I've never seen before on a simple cable test. The power supply is reporting a consistent 2.07 amps. So I'm not quite sure what's going on here. It seems to be floating around 4.8 volts though. Ignoring this up and down jumping. So that is weird. But 0.2 volt loss at 2.1 amps is actually very good. Just for the sake of completeness. Point 2 divided by 5 times by 100. 4%. It's only a short cable, so but that's on the good side. I mean, that's much better than many cables. So the fan's just turned on this, so it's obviously warmed up. It's still jumping around a little bit, but yeah, no, still quite a bit. But this cable at 4% for a short cable, this is fine. That's good. Much better than a lot of cheap power bank cables. I just want to test, see whether something weird going on. So, reference anchor cable, for the sake of consistency. So that's settling reasonably well. 2.1 plus or minus a little bit is normal, but so you can see, I mean, the anchor one's nearly 3 times the length of that, and it's showing the same sort of percentage. So there's still no replacement for a good quality cable, but for a freebie one that comes with the power bank, this is absolutely fine. Nothing wrong with that. That is still a little bit bizarre, but it's fine. There's nothing. I don't know why it's jumping around quite so much, but it's okay. So I'm going to charge this back up. I'm going to have a play with the QuickCharge functionality and see if I can figure out why it's not allowing me to select voltages, and then once I've figured that out, then we'll do the capacity test back in a bit. Right, I don't know that I would go as far as mystery solved, but I've got somewhere. So first things first, I started charging this up, and it immediately, I've been playing with it, so it probably dropped a little bit, but it quite quickly jumped to showing the second blob charging. So I think this has come with somewhere between 25 and 50% charge. It's been on my shelf for a few weeks. According to the box, it was 2018-01. So if this was made in January, then it's still got somewhere in the region of 25% of its capacity left, so it's not too bad. So the interesting thing is, if you plug in to the port that I was testing, nothing happens. So when I've reprogrammed this to drop it into 9 volts when it does the initialization. So when I press reset, nothing's happened. However, if you plug it into this one, which does show a slightly higher voltage by default, 5.16 volts instead of 4.97, if I then do the reset, this should There we go. So it's jumped to 9 volts as requested. But so using QuickCharge 3, these buttons should allow a selection of volts plus or minus 0.2 at a time. So it looks like this only supports QuickCharge 2 or the QuickCharge 2 things. And if I make it 12 volts, let me turn this on. And reprogram this. 1 second. Get there fast enough. This should jump to 12 volts. There we go. So it does indeed support QuickCharge, and this does work, but it doesn't. This doesn't seem to support continuous mode of QuickCharge 3, which is a bit of a disappointment. But it's fine. I mean, it only claims to support. Again, on the box. Focus. It only claims to support 5.1, 9 volt, 12 volt, so I can't really argue that. It is what it is. So I'm going to probably do the discharge test at 12 volts because it minimises the loss in the cable, and it's the highest voltage that this can output, so it'll be interesting to see how that works. But yeah, so mystery solved. The other thing that's interesting, there's 2 other things I wanted to test. The first one is, and this is interesting, if you plug in this, and let's jump it to 12 volts, which it now is. If I then plug in a second meter, I use this one because it actually fits next to this one, they reset. This one resets. So this port is at 4.9 volts, that port is at 4.9 volts. If I then do a reset to, in theory, this select back to 12 volts, nothing happens. So when you have 2 devices plugged in, it only supports 5 volt output. You can't do QuickCharge on both ports. In fact, you can't do QuickCharge on any port by the looks of things if 2 devices are plugged in. So that's worth noting, and it appears that it only does QuickCharge on this port, not on this port. So that's good to know. And then the final thing I wanted to test, which I know some power bank support and some don't, is pass-through. Does pass-through power work? Press the button. Oop, nothing. So when it's charging, so 2 blobs. Oh, yes, it has lit up. So that's interesting. So it does seem to support pass-through power. So that's good to know. I don't know what. Let's have a look. Plug in the little load. Powered up just fine. 2.2 amps, that's still in. Let's drop that slightly. 2.1 amps, 4.7 volts, so that does seem to work. So pass-through power supported. If I unplug it, I assume that will reset, which it has. And now it's outputting close to 5 volts. So there's a bit of voltage drop, so I don't know how much. While it's on external power, I guess it's just passing power through and it's not going through the conversion process. It might be, but probably less likely. But it's good to know that does work. So you can potentially use this power bank as a emergency light or a UPS for a Raspberry Pi or something, as long as you accept the caveat that when the power comes on and off, this thing will reset whatever load you're running on it. But still good to know. Right, I'll let this charge up for the capacity test. The other thing I haven't tested, and it's like I've forgotten how to do these while I've been on holiday, is what's the combined output of both ports. Now it's a bit of a squeeze. I can just about get two things in. So if I put this into 2 amp output mode, and then if that fits, it does just. So this port is drawing 2 amps. How far can we push this one? Can we do 2 amps on this port? 3 amps in total. All voltage drops off significantly there. So 1 point, just over 3 amps, the voltage starts to drop off. So it's not 2.1 amps, 2 amps, 2.4 amps I think it said, in total. But it will do one at 3 amps. So it's advertising 2.1, which is what you'd expect, probably. Let me just reset that. This port advertises 2.4 amps, and on a fresh, this port advertises 2.1 amps. So they're actually advertising different power capacities, with a combined total of 4.5 amps. But it can't do that, it can do 3 and a bit. So where it says here 2 times 5.1 at 2.4 amps, bit misleading. It won't do 2 times 2.4 amps, but I've let other power banks go with that, so I can't really complain. So that's, yeah, it's okay. It'll happily charge a high capacity device in an iPad and a phone or something without too much effort, so that's fine. Reasonably happy with that. So going back to charging this up, I'm going to finish the charging with this, the cable it came with. I plug it into the meter for a milliamp hour reading, just so we get some idea. And as you can see, it's still on 2 blobs, so I haven't excessively charged it. So we'll see how many milliamp hours this thing takes to charge when it's ready. Right, it's currently drawing about 25 milliamps at 9 volts, and if you look at the little display, you can see all 4 blobs are no longer flashing, so it seems to be charged and just trickling. Before I carry on with the capacity test, I wanted to talk a little bit about QuickCharge and some things that I've done with this power bank. So the first thing is when charging up it, I'm doing the follow-up the following day, and while it was charging it drew 2 amps at 9 volts, which is 18 watts, and it took 4,365 milliampere hours at 9 volts, which is 38,674 milliwatt hours, or 38.6 watt hours. Now, the actual capacity of the power bank is 37 watt hours. But that's not a massive surprise. I mean, there's some loss in conversion from, in this case, 9 volts down to whatever the batteries need. So the fact that it's put in 38, nearly 39 watt hours to charge a 37 watt hour battery is not up to about from about 20-25% is not unexpected. But it's an indicator that as I've seen with these before, it's not a terribly efficient process, the charging thing. The other thing that's interesting is this comes with a little hologram sticker with a number on it, and if you scrape the number off, scrape the plastic, the sort of silvery covering off, there's a number, and you can put that into Xiaomi's website, and it tells you whether or not the product is genuine. This is a genuine product, which is nice to know. It's the first time that number had been used. So I'm quite pleased with that. Looking a bit more carefully, the reason why my QuickCharge 3 device didn't work quite as well as expected is that this device does not support QuickCharge 3. The listing on Banggood is incorrect there. It is I don't think you'll be able to see this. There we go. Refocus. It's a PLM09ZM, which is a China-specific model. And it seems to be the case that the PLM01ZM, which seems to be what this is based on, supports QuickCharge 2. This supports QuickCharge 2. There is also a PLM03ZM, which does support QuickCharge 3. And there are a couple of other variants. There's a PLM02ZM, which you can buy, but only has one USB port. So this particular version appears to be unique to the China market, and comes with 2 USB ports, which obviously is a bit more helpful. But yes, QuickCharge 2, not QuickCharge 3, which is why I had to bodge this to do the QuickCharge 2 negotiation. So why is QuickCharge 2 and 3, why is QuickCharge good? It increases the voltage that the USB port outputs. So in a USB port, I've got a socket here, there's 4 little connectors, which you can just see if I angle it correctly, and the same in a socket. When they fit together, they're up together. Now each of these has a purpose. In this case, these are labelled on this little breakout board, but you've got VBus, which is normally, let's focus, close enough. So normally you would, for standard USB, this will be 5 volts. D plus and D minus are the data lines normally, and ground is effectively 0 volts. And the way QuickCharge works is a diagram I did earlier. So, excuse the little terrible diagrams, but that as a USB plug, and that as a US corresponding socket. And the way this works is that normally you get 5 volts supplied on the positive pin, and the minus pin is referenced to ground. And what happens is that for QuickCharge, the device can negotiate a different voltage by changing the voltage on the D plus and D minus pins. So the device outputs a certain voltage on these pins. So for D minus and D plus, depending on which voltage is output, for QuickCharge 2, you can choose 5 volts, 9 volts, or 12 volts, normally for most devices. And the way that you do that is that, say you wanted 12 volts, you'd output somewhere around the region of 0.6 volts for both the D plus and the D minus pins. If you wanted 9 volts, you'd output 0.6 volts on the D minus pin and 3.3 volts on the D plus pin, and then you'd get 9 volts on the positive pin. With QuickCharge 3, there's also this zone called continuous, where once you've put it into that mode, the power bank then, not power bank, or the power supply, the power bank, then knows that if you jump into the 20 volt range, or down to the 12 volt range, that way increases the voltage by 0.2 volts, and that way decreases the voltage by 0.2 volts, which is what my 2 button presses do. They effectively, the green one causes a jump that way, and the red one causes a jump that way. But that doesn't work for a device that's QuickCharge 2 only, so that's why that didn't work. But this does support 9 volt, 12 volt and 5 volt output. I've tested it, those work fine, so that's good news. The reason why this is good is because when you have a bit of wire, any bit of wire, you're going to lose some power. So any of you who've done any quantity, let's see about fixing there we go. Any of you who've done any electronics know that the power going through something is equal to the voltage times by the current. And so let's say you've got a USB supply at 5 volts times by 2 amps gives you 10 watts. Now the thing about current is that a USB cable, or any cable, loses some power in the transfer. It's just a feature of all cables have a bit of resistance, and that resistance causes voltage drop. But the amount you lose is a proportion of the current. So a typical USB cable, and I'm going to use some nice round numbers here, might lose 10% at 2 amps and maybe 5% at 1 amp. Now, losing a small percentage of the power in the transfer, you always lose a little bit, in connectors, you lose a little bit in the conversion from 3.7 volts of the lithium cells to 5 volts for USB, but generally minimizing this is a good thing. So let's say you've got a 5 volt supply at 2 amps and you're losing 10% of that. You're actually then typically be seeing 4.5 volts at the other end. Still 2 amps though, that stays the same, but that only gives you 4.5 times 2, which is 9 watts of power. Now obviously that's not it's not a huge loss, 10%, you can live with that. But the alternative, and what QuickCharge effectively does, is it allows the device to choose to accept a higher voltage at a lower current, which reduces the loss slightly. So you might then choose to accept, instead of 5 volts, with QuickCharge 3 you could choose 10 volts. So we'd keep that because it keeps the numbers nice and round. So 10 volts at 1 amp, say. Now 10 volts at 1 amp, you'd then have 5% loss in our theoretical cable. Now 5% loss of 10 volts is also 0.5 of a volt. So actually you've got 9.5 volts times by 1 amp equals 9.5 watts. So effectively you're seeing a little bit of extra power. It's the same power being output by the power bank. The power bank is outputting 10 watts at its end, but instead of losing 1 watt in the cable transfer, you're only losing half a watt. And that's good. Obviously, the more efficient, the better. The other thing that it gives you the possibility is actually to increase the power. So USB, typical maximum for most an iPad or some high-draw device would be 5 volts at 2.4 amps. This one, it actually outputs 5.1, but it's around 12 watts, give or take. Some power supplies do boost the voltage ever so slightly, but typically the maximum you'll see is 12 watts. Whereas, this QuickCharge one actually has the numbers on the bottom, I think. You can't really see those. They're better on here. So 12 volts, 1.2 amps. So we've got it'll output 9 volts, or it'll output 12 volts. The 9 volt figure is at 1.6 amps. The 12 volt figure is at 1.2 amps. And that is 14.4 watts. And that is 14.4 watts. So by choosing to boost the voltage and drop the amps, you're suffering less loss in the power cable, and it also means that provided your device can support that amount of current, you can supply nearly 15 watts of power instead of 12 watts. So again, this all helps to charge your device more quickly. As long as the device is capable of negotiating that and the charger is capable of delivering it, it means quicker charging, less loss in the cable. This is a good thing. USB-C uses the power delivery standard, which works totally differently to this. So this is not how power delivery works, USB PD. If you have a USB-C cable, it'll be capable, or a USB-C charger, usually they're capable of adjusting the voltage, but it's via a completely different method, but the benefits are the same. So that's progress. I think it's a good thing. It means we can get a bit more power out of the ports without losing so much, and our devices charge quicker. So there's no downside, really. I apologise if that was a bit long-winded and confusing to some of you. It's one of those things I didn't want to kind of assume everybody understood the reasons for this. So yes, so this does charge. It requests 9 volts from this particular QuickCharge capable charger. It draws 2 amps, which means it charges at 18 watts instead of the 12 watts. So it means that this charges up a bit more quickly than some other devices might do, which again is a good thing. think that's almost it. So the only other thing, I did test this at low current, for low current, and there's two ways to make it do that. One is if you double press the power button, this is a supported mode of the device, it turns the output on for 2 hours no matter what the current draw is. So if you've got something very low current, it will continue to supply power. Something, you know, very small that you're trying to charge, or a low power night light or something, it'll run that for 2 hours regardless and then turn it off. If you plug something low power in, it needs to draw more than 30 milliamps for this to leave the power on. So the hold on power is 30 milliamps, which I've had a request from somebody to look into. It's a bit of a faff checking that, because you basically just have to keep dialing the power down and then wait a couple of minutes to see if it turns off, but I did that offline. So yeah, 30 milliamps hold on current, but you can bypass that with a double press of the power button and it will keep the thing on for 2 hours. Not so good if you've got a low current drain you want to keep on for longer than 2 hours, but it is better than nothing. So this is trickling at the same rate, so I'm considering this sufficiently charged that we're ready to start the capacity test. I'm going to do it the normal way, using USB 5 volts just to keep everything consistent with previous videos. And the other thing, the good news is, in the meantime my replacement little blue meter has turned up, so I do need to just check that this is as accurate as the last one is. I'm going to do that now, and then I'll get set up for the discharge test. Right, we're ready to start the discharge test. Now what I am going to do is stop this video just as I start and put it into time-lapse mode, which should reduce the size of the video that I have to process for the sped up section, so that'll be a bit different from previous videos. The other thing I ought to say is that for my little QuickCharge testing device, I was going to build one of these myself, like properly from scratch, but it turns out that there's some already an open source project for the Arduino that supports QuickCharge 2 and was then upgraded to support QuickCharge 3. I'll include a link to that in the description, because it meant that all I had to do was build this board. The software library was already written, and somebody had worked out all the maths for the right resistor values to make it work, so that saved me a dramatic amount of time, and for that I'm extremely grateful. So I will include a link to the QC3 control project, but that's really good if you're looking to do QuickCharge 2 or 3 emulation and you've got an Arduino. Brilliant project. So the discharge, the power bank is charged and ready to go. I'm going to try and step it up on my little stand so that hopefully you can see. This little meter seems to be fine, so that's good. Which way around? That way. I do still need to peel the protective plastic off that, but a good little display, marvellous. So hopefully you can see that. Yep. So oscilloscope showing 5.1 volts. That's showing 5.1 volts. So let's dial it up to 2.4 amps. So 2.4 amps, 2.4 amps. Oscilloscope showing 2.4 amps, nice. So there'll be a little bit of voltage loss through the wiring through the shunt, so that's fine, nothing wrong with that on the oscilloscope. And again, the voltage loss to the load will be due to the wiring in the shunt, which is fine. And that's powered off because I haven't reset the power off thing. So I press a button, that will come back on. Let me see if I can remember how this works. Hopefully I can do this without... Yeah. That's it. 0 minutes. There we go. So that should stay on now. So now we just have to watch the video and let it get on with it. So I'm going to stop this video and put it into time-lapse mode and then leave it to go. So, summary time. It has finished discharging. It ran for about 2.5 hours, a little bit over that, which is more or less as expected. So I think what we want to do is just verify the power figures on this meter. I have checked the video, but it probably makes sense. Let's get this exactly in focus. So you can see here, it's reading 33,621 milliwatt hours, which is pretty good. If we feed that into the calculator, what was it, 33621, divide by 37,000, so it's a 37 watt hour power bank, times by 100, 90.86% efficient, which is great. I mean, that is, they claim in the description that it's greater than 90% efficient, and it is exactly that, and that's very good. A lot of power banks are closer to the 80% or even well below 80% in the case of some poor ones, but one that's 90% is brilliant. You're paying for, you know, capacity of a power bank, and that is exactly what you want. Is the more efficient it is, the more charges you get for your phone or whatever. So that's great. So yeah, I'm impressed with that. That's a very nice figure. In terms of other things, this particular model seems to be exclusive to the Chinese market. You can get it from Banggood, which is where I got this one from. I haven't tested. I mean, it might be interesting to test one of the UK market versions, but they do only come with one USB port, and they're a bit over £20 instead of 17ish. So it swings around about. This one, it seems perfectly fine. Pretty good, actually, to be honest. I'm sure the UK market ones are also good, but I personally at this point wouldn't pay the extra to have one less USB port. So as I said, the standby current, the hold-on current for this is 30 milliamps, which is okay. You can force the power to stay on for low current devices like headphones or smartwatches or whatever by double pressing the power button. It'll stay on for 2 hours. This port does, looking a bit, let me adjust the brightness, hasn't really helped. This port does QuickCharge 2, this port doesn't do QuickCharge 2. If you use both ports, you're stuck at 5 volts, which is a bit of an annoyance, but again, not the end of the world. The cable it came with, which is here, does seem a little bit odd. I'm not quite sure what the cause of the jumping around was, but it's not the end of the world. Whether or not it's feature of this cable, I don't know, but it seems okay in terms of its power loss. It's pretty respectable. It's a reasonable length. It's certainly one of the better cables that comes with a power bank that I've seen, so that's fine. So good capacity, quick charge too, reasonable cable. It was £17.80, I think, which was not the cheapest power bank for 10,000 milliamp hours, but it's also not ridiculously expensive. It's reasonable quality. It cut the power off cleanly during the discharge test, so once it was empty there was no flickering on and off. It was a consistent 5 volts exactly all the way through the test, and it output 2.4 amps consistently all the way through the test. So in terms of the power test, it's aced it. It's very good. As I say, it's not the cheapest 10,000 milliamp hour power bank, but if you want a quality one, you could do a lot worse than this. So I'm going to go so far as to say I would recommend this one. It's nice, feels good, good weight. One final update to this video. I did a bit more playing about. I've now fully added QuickCharge 2 support and QuickCharge 3 support to this, so I've got a way of switching between them. And as part of that testing, I was doing a little bit of playing with this power bank, and it appears that both ports do in fact support QuickCharge 2. So if I reset this, I can now change voltage 5, 9, and 12 volts, so I can switch between them at will. And if I switch to the other port, just to prove that I'm not playing about, do a quick reset of this, and get 12, 5 and 9 volts.